So let's have a look at this problem. We obviously can do risk difference, relative risk and odds ratio. So our problem is the following. Researchers, they randomly select 242 subjects from a population of people in care facilities. So a cross-sectional study design, these people are just selected at random, irrespective of all their attributes. So a random proportion of the subjects are veterans, and a number of these subjects suffer from sleep disorder. So there's our two categorical variables. They both seem to be binary in as much as there's only two possible categories for either of these variables. So the researchers want to test the claim that the risk of sleep disorder is different in veterans compared to non-veterans. So the way that we can look at that later on we will do is just look at a chi-square test, obviously, but now we want these measures of association. So what they find is that a total of 77 veterans had a sleep disorder and 45 did not, and 35 non-veterans had a sleep disorder and 85 did not. And we have to calculate the risk, the risk difference, that's the difference in risk for sleep disorder comparing veterans to non-veterans, the relative risk of a sleep disorder comparing veterans to non-veterans, and the odds ratio of a sleep disorder. So the odds of a sleep disorder, again, then comparing veterans to non-veterans. So we also have to calculate the confidence interval of all three, the risk difference, relative risk, and the odds ratio, and we have to interpret those results. We have to use a level of significance of 5% and then a confidence interval of 95%. So consider this risk, these three measures of association. So what we have here is our table. We summarize the table, and what we could do is let's just assign what we have. Let's get the right pen out. I think this one will do. Let's call this we're free to do this, but let's call this our exposure group, and then we'll say these people were not exposed. Let's make this the disease, and then that's this non-disease, so that we can just use the symbols that we are used to. So let's also just start then with the first of our three measures of association. We're going to start with the risk difference. We're going to start with the risk difference. So what we have for risk difference is we have these two conditional probabilities. Remember, we have the probability of disease given exposure, and we have the probability of disease without exposure. So irrespective of our study design, we have to have that our disease and not disease, that the choice between those categories are random. But through a cross-sectional study design, both of these are random anyway. We just selected 242 subjects from this population in care facilities, and so both of these were actually random. But what we're really interested in, specifically for risk difference and relative risk or risk ratio, is that disease and not disease must be random events. And so this one's quite easy. If we look at everyone who was exposed, that is that first row, so the denominator's got to be 122. How many of them had sleep disorder? Well, there was 77. So that's clearly going to be 77 divided by 122. And if we look at this, the probability of disease in the unexposed, well, there were 120 that were not exposed. So I'm conditioning upon only those that were not exposed. How many of them developed? Well, 35 of these developed. And if you plug those into your calculator, you should get about, check if you get the same as me, I get 0.631 and I get 0.292, about 0.292. So those are my two, and just, another symbol that we can use is this is just P sub 1 and P sub 2 for these. Those two proportions, remember, proportion, risk, probability, these are going to be synonyms for us. So let's remember how to calculate the risk difference. The risk difference, well, that's going to be the probability of disease given exposure minus the probability of disease in those that were not exposed. So that will be the same as P1 minus P2 in, using those symbols. So if we were to do that, let's have a look at it. I get a risk difference that is going to be 0.631 minus 0.292. If you plug that in your calculator, I get 0.339. So that's 33.9 percentage points. So let's write a conclusion here. So I can write there is a 33.9 percentage point increase in the risk of a sleep disorder for veterans compared to non-veterans. Why can I say an increase? Because that value was bigger than that. So I get a positive result, a positive risk difference. So I'm going to call that a percentage point increase. If this was negative, I would say a percentage point decrease. Do remember, instead of the percent symbol, we do like to write percentage point when it comes to risk difference. And so that's not enough. We also want to calculate the confidence interval. So I'm going to say that is the risk difference plus or minus some confidence coefficient times some standard error. And the standard error is very easy to do. That's my probability of success. So that's going to be P sub 1, 1 minus P sub 1, divided by N sub 1, where N sub 1 is the number that was exposed. Now I'm going to go to P sub 2, 1 minus P sub 2, divided by N sub 2. Let's get out today. I've got my trusty NVIDIA, not sponsored. That's a little joke. Anyway, there we go. That is my confidence coefficient. We do know that the risk difference is normally distributed under the null hypothesis. If we were to do a study hypothesis for this, plus or minus the confidence coefficient, this being normally distributed for a alpha value of 0.05. If you work that out for two-tailed alternative hypothesis, you get your confidence coefficient is going to be 1.96. Remember the z distribution, and then times the standard error. Remember c times the standard error, that gets us our margin of error. So if you plug all of that into a calculator for a c value of 1.96, confidence coefficient of 1.96, that means 1.96 standard errors away from 0 on the z distribution, I get the lower bound of, I get 0.221 to an upper bound. My upper bound is 0.457. So we're saying that there is a 33.9 percentage point increase in the risk with a 95% confidence interval of 22.1 percentage point increase to a 45.7 percentage point increase. And now look, if there was no difference in the risk between these two categories, between those that were exposed and those were not exposed, under null hypothesis we would state that there's zero, there's no difference. If I do subtract one from the other, I should get 0. But look at this interval here. 0 is not in this interval. I'm 95% confident that there is a percentage point increase in the risk. It's between 22.1% and a 45.7% increase. 0 is not in there, and this would be, using confidence intervals, the same as then saying, well, we reject the null hypothesis and accept the alternative hypothesis. That would have been that, yes, there is an increased risk in sleep disorder for these veterans. So let's see if we can express this as a relative risk. And remember, relative risk is also called a risk ratio. So where that was a risk difference minus the risk ratio, let's put that in green. That is our equation. So we're going to say that a relative risk or risk ratio, well, that's going to be the probability of disease given exposure, and we're going to divide that by probability of disease in the non-exposed. So that would be P sub 1 divided by P sub 2 if we use those symbols. So instead of multiplying these, we are dividing that. So our relative risk or risk ratio, that's going to be 0.631 divided by 0.292. You plug that in your calculator. Let me see what I got. About 2.16. Let's write the conclusion. So I wrote veterans have about 2.16 times the risk of a sleep disorder compared to non-veterans. Can we express this as a percentage increase? Yes, remember, that value is larger than 1, so I'm going to subtract 1 from it, which leaves me with 1.16. Let me write that in orange, or let me write that in pencil. So I'm going to say the following: 2.16 minus 1.0, that equals 1.16. If I multiply that by 100%, that equals 116%. So I could also write the following. So I wrote veterans have 116% increased risk of sleep disorder compared to non-veterans. So being a veteran increases your risk of a sleep disorder by 116% compared to non-veteran. Remember, it's because this was larger than 1, I subtract 1 from it. If this was smaller than 1, say 0.4, I would say 1 minus 0.4, which leaves me with 0.6, which is 60%, and I would then claim there's a 60% decreased risk of a sleep disorder. So let's do the following. I just want to get my orange pen. I'm going to call this N sub 1, 1, N sub 1, 2, N sub 2, 1, N sub 2, 2. So when we do write this out, we do remember that the relative risk or risk ratio is not normally distributed under the null hypothesis. So we have to do a transformation of this. So we're going to say the following. Is this my green pen? Yes. So for the confidence interval, we're going to say the natural log of the relative risk plus or minus. And we're going to then have a confidence coefficient. C, because once we've taken this transformation of this relative risk, then we're going to say that it's approximately normally distributed, so we can use the confidence coefficient C, and then we're going to have the following. So we always have to write this down or look at our formula sheet. There's no reason to try and memorize this. I've got n sub 1, 2, and I'm going to divide. Oh, that's a horrible line. I should use my trusty ruler. I've got n sub 1, 1, and then I'm going to multiply that by n sub 1, 1 plus n sub 1, 2, and I'm going to add to that n sub 2, 2, and I'm going to divide that by n sub 2, 1, multiplied by n sub 2, 1, plus n sub 2, 2. So that is what my C times this, the standard error, that's going to be my margin of error, and I have to take the natural log of my confidence coefficient. So let's do that. If I plug that into my calculator, I'm going to get the following. I'm going to get a lower bound, so that's the natural log of 2.61 plus, or let's do the lower one, minus C times the square root, and you're going to plug in those values, 77, 35, 45, 85, into our equation there. I get 0.461. If I plug that in, and if I do plus 1.96 times the square root, I get 1.081. But now I do remember that I have to take the exponent of these. I have to take the inverse function of this natural logarithm. So I have to have, say, e to the power 0.461 to e to the power 1.081. And I get, when I do that, I get the following. I get 1.59 all the way up to 2.95. Now look again, that is my relative risk. And 1, under the null hypothesis, if these two things are the same, if I divide something by itself, I get 1. So under the null hypothesis, there'd be a 1 there. But look, 1 is not in there. In actual fact, I could express this as a 1, remember that 1.59 minus 1 is 0.59 times 100% would be 59%. This would be 195%. So I would say I'm 95% confident that the increased risk in the sleep disorder comparing veterans to non-veterans is between 59% increase and 195% increase. Clearly, 1 is not in this interval, and therefore we'd fail to reject the null hypothesis. We are going to say that this risk is increased by this percentage, 116%, comparing the veterans to the non-veterans. And in actual fact, we're 95% confident that this increase in the risk is between 59% and 195%. Great, let's look at the odds ratio. Now remember, the odds ratio is very nice because the odds ratio, if you look at the exposed or you look at the disease, those two odds ratios are exactly the same. Remember, odds is probability of success divided by probability of failure. But remember, let's write this out. The odds ratio is always very easy. That's going to be n sub 1, 1 times n sub 2, 2 divided by n sub 1, 2 divided by n sub 2, 1. So let's write that out. So if we look at our previous page, it's always going to be the product of this main diagonal, 77 times 85, divided by the product of this cross diagonal, 45 times 35. And if you do that, let me get my calculator, I get that the odds ratio is about, trying to put my little squiggly lines there, 4.16. 4.16. So I could write something that the odds of having a sleep disorder are about 4.16 times higher in veterans compared to non-veterans. But let's express this as a percentage. Once again, this is larger than 1, so I'm going to subtract 1 from it. 4.16 minus 1.0, that equals 3.16 times 100%. And that leaves me with 316%. So there's a 316% increase in the odds of. Let's write that out. So I've written there's a 316% increase in the odds of a sleep disorder for veterans compared to non-veterans. So remember, once again, if this value, 4.16, if it was lower than 1, so again like 0.4, that would be 1 minus 0.4. That leaves me with 0.6, and I'd say there's a 60% decrease in the odds. And so that's a very easy calculation. We just have to remember how to calculate the 95% confidence interval. And so remember, if we want that, it's again the natural odds of the odds ratio, because the odds ratio again is not normally distributed, and we transform that by taking the natural log of the odds ratio. That is going to be plus or minus C. Now it's normally distributed, so our confidence coefficient can then be C, and for 95% confidence interval or an alpha value of 0.05, that would be 1.96 times the square root of 1 over n sub 1, 1 plus 1 over n sub 1, 2 plus 1 over n sub 2, 1 plus 1 over n sub 2, 2. So I'm just going to say 1 over each of those joint frequencies. And if I do that, if I plug in 1.96 there, I get, check on your calculator, I get 0.887, and I get, let me just check, 965, but I do remember that I have to exponentiate these, 0.887 all the way to e to the power 1.965, and that leaves me with the following. It leaves me with a lower bound of 2.43 and an upper bound of, my calculator says, 7.13. So again, this would be a 143% increase all the way up to a 613% increase. Once again, one, the odds being the same for both these groups is not in this interval, and hence again, we reject the null hypothesis. There is an increase in the odds. There's a significant increase in the risk of odds comparing veterans to non-veterans, odds of sleep disorder comparing veterans to non-veterans. So much so that we are 95% confident that this increase in this odds of a sleep disorder is between 143% increase to 613% increase. So that's it. When it comes to problems pertaining to risk difference, relative risk, and odds ratio, it is fairly simple to do. So this is what I've done in ChatGPT. As you can see, I'm using ChatGPT 03 Mini High. I've plugged in our problem and I've written my prompt there. I will copy and paste the prompt in the description down below. If you want to copy and paste it into ChatGPT or one of the other large language models, you can certainly have a look at what it says. Remember, I do start my prompt with help me with the following biostatistics problem. And then everywhere where there is a value or some kind of equation, I do use, just be careful, I do use the dollar symbols in front and back. That is LaTeX or LaTeX notation, mathematical typesetting, so that I can write something like this. I'm writing alpha equals 5%. See that backslash alpha? That is typeset as the Greek symbol alpha. And so I do like to use this typesetting. Otherwise, if I want to put in an equation, it's very difficult to put an equation in words. And so my preference is to use LaTeX or LaTeX, and it works very well, at least for me, for ChatGPT, as opposed to some of the other models. So there is our contingency table. So ChatGPT made this contingency table from the information that we were given. We were given these joint frequencies, like 77 veterans had a sleep disorder and 45 did not, and we see the 77-45, so that's great. It starts with a risk difference, and it works out these two risk differences. It works out our probability of sleep disorder given a veteran and probability of sleep disorder given not a veteran. So it works it out. It works out the risk difference, same as we got, 33.9 percentage points. And it says this means that the absolute risk difference is about 33.9 percentage points. That's great. It works out the standard error of the risk difference, and we see the equation that we used. We can see plugging in those values. You can pause the video and have a look at that. That looks exactly like ours, and margin of error 1.96 times the standard error. And so we're going to add and subtract that from the risk difference, and we get the same percentage point for the 95% confidence interval, 22.1 percentage points to 45.7% percentage point increase in the risk of sleep disorder, given that you are a veteran compared to not being a veteran. So for the relative risk, it's obviously dividing those two, so they get a relative risk or risk ratio of 2.16. That's exactly what we have. And it's stated there, this indicates that the veterans have about 2.1 times the risk of having a sleep disorder compared to non-veterans. And now it's doing the confidence interval, and look at that. That's the standard error of the natural log of you've got to take the natural log. And that's how we do it. You can see this algebraic form is different from the one that we use, but you're going to see the results are exactly the same. And so we take the natural log of that, of 2.16. If you do the calculator, that would be 0.771. And so we're going to take 0.771 plus or minus 1.96 times the standard error. And you get your two values, 0.461 and 1.081, but you do remember that you have to exponentiate those. So e to the power 0.461, e to the power 1.081. And now we get our 95% confidence intervals for the relative risk. It's 1.59 to 2.95, exactly as we had in our problem. When it comes to the odds ratio, it does AED divided by BC, which I don't like. Don't like that. But anyway, the numbers are going to be the same. Across the main diagonal, 77 times 35, divided by the cross diagonal, 45 times 35. And we get an odds ratio of 4.16. And now we just have to calculate that, or at least I see very nicely there it says this means that the odds of having a sleep disorder are about 4.16 times higher in veterans compared to non-veterans. Now the confidence interval, remember we have to take the natural log of the odds ratio, and then it's just 1 over each of the joint frequencies. And so again, if we go through all of that, we see that we have the natural log of our odds ratio turns out to be 1.4261 plus or minus C is 1.96 over there times the standard error. And we get our two values there, but we have to remember to exponentiate those. So we see e to the power 0.887 and e to the power 1.975. So eventually we get our odds ratios of 2.43 to 7.13. That's 143% to 613% increase in the odds of a sleep disorder comparing the veterans to the non-veterans. So that is very good. We see as well that we get the nice interpretation of the results. The point estimate of 0.339, 95% confidence interval 0.221 to 0.457 indicates that veterans have an absolute 33.9% higher risk in sleep disorder compared to non-veterans. So it's putting percent there, but we do like to say percentage point. And it's doing the same for relative risk and odds ratio. I will let you pause that and read that. And we see another little summary there, very nicely done. I've also said there, my next prompt was to express this as a percentage point, and look what it does. It says 2.16 minus 1, that's 116%, and for the odds ratio, 4.16 minus 1 times 100%, that's 316%. So I think perfectly well done by ChatGPT.